Hello everyone. In this video we're going to talk about how to simplify radicals. There's a few different ways that you can simplify radicals. I'm going to show you two of the best and easiest ways that you can simplify them. We're going to start off with the square root of 75. The first way that I'm going to explain is you need to think of perfect squares that are factors of 75. So we have 1 squared, which is 1, 2 squared is 4, 3 squared is 9, and then we can keep going from there. We ask ourselves which one of these numbers is a factor of 75. If you said 25, you were right. 75 is 25 times 3. When we have multiplication inside of a square root, we can break down the square root. Square root of 25 times 3 is the square root of 25 times the square root of 3. We know that the square root of 25 is 5 times the square root of 3. Now here's another way that we can simplify this radical. Let's say we had square root of 75. We can use prime factorization to break down the number. We know that 75 is 25 times 3. 25 is 5 times 5. And all of these numbers at the ends are all prime numbers. So since we have a square root, there's an imaginary 2 here that we do not need to write. This means that we need a pair in order to come out as one term. So when we break down our numbers into the factor tree, the prime factor tree, we're looking for numbers that show up twice. As we can see, 5 shows up twice. The square root of 25 is 5. So therefore it comes out, and then since there's only 1 3 left over, this is going to stay inside of the radical. And we'll end up with the same answer, 5 times the square root of 3. Let's say we have the square root of 32. Once again, we can think about which numbers in this list is a factor of 32. We know that 4 is a factor, but the biggest factor that's a perfect square is going to be 16. 32 is 16 times 2. We can separate the square root when we have multiplication on the inside. And we know that the square root of 16 is going to be 4 times square root of 2. The other way we can solve this radical is by doing a factor tree. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And then finally 4 is 2 times 2. And our goal here is to try to find pairs in this factor tree so that we can simplify them out of the square root. So here we have 1 pair of 2's. Here we have 2 pairs of 2's. So we can write this first pair, 2, times the second pair, 2. And then we have a 2 left over. Everything that's not at the end of one of the branches, we can ignore or not take into account. So since there's only 1 2 left over, that's what's going to stay inside of the square root. And on the outside we have 2 times 2, which is 4, times the square root of 2, which is the exact same thing we got on the other side. Next, we will have the square root of 50. We know that 50 is 25 times 2. Remember, we're thinking of perfect squares or numbers from this list that are factors of the number inside of the square root. We know that 50 is 25 times 2, and 25 is a perfect square. So we can break down this square root into square root of 25 times square root of 2. Square root of 25 is 5 times the square root of 2. So now let's try it using prime factorization. 50 is 25 times 2, and 25 is 5 times 5. Remember, we're looking for numbers that show up twice in our factor tree. The reason why we're looking for numbers that show up twice is because whenever we're dealing with a square root, there's an imaginary 2 right there. So this 5 shows up twice. We're going to write it once. And then we have a 2 left over. So square root of 2. Once again, the exact same thing we got on both ends.